welcome back who's been in the previous session for us, who hasn't been part of MQ Stream just yet, welcome as well. My name is Raminta and I'm hosting MQ Stream. And today we're going to have a presentation about MQ accounting statistics from Morag, who will introduce herself a bit further. And yeah, let's just please enjoy our presentation. And thank you very much, Morag, for presenting. The floor is yours.
Thank you very much. Okay, hi guys. I'm Morag and I once used to work in IBM Hersley, but these days I am no longer an IBMer, but I'm still an MQer. I still do MQ as my day job. I work for MQGem Software, which is an ISV that writes tools for MQ. I have been elbow deep in the bits and bytes of IBM MQ's accounting and statistics on the distributed platforms of late. So I thought it might be worth having some time to tell you all about what is in there and what it can do for you. I have come to the conclusion that there are many queue managers out there in the world that do not have accounting and statistics turned on. And that's probably for a couple of reasons. Maybe the people running those queue managers haven't found a good way of capturing and viewing that data yet, or maybe they just don't know what they're missing out on, what the data shows you that you could be using. So I wanted to try and rectify some of that, give accounting and statistics a bit of a cheerleading capacity, see if we can persuade more people to make use of it and learn what it's trying to tell you about your queue manager and about your application. So that's my aim, is to leave you with a better understanding of what's in accounting and statistics and what you might learn from it if you make use of it. So that's today's session. This is a distributed platform session, not a ZOS session. I know GSC is a ZOS conference, but I also know that lots of MQ teams are both ZOS and distributed. You can't do one without the other. You would never want to do one without the other. How do you get all your data onto the ZOS machine? You get it from places off platform and it comes in over MQ. So you need to know both, and you need both to be running efficiently. So last conference, or maybe the conference before, there was an equivalent presentation about ZOS SMF statistics. Today, you're getting one about distributed, because you need to know both. So that's the idea. Anyway, I just wanted to say, in case you hadn't noticed, there is a handout. So if you look on the agenda, or the bring your own agenda, wherever you click the link from, you'll see this little, I think it's a little guy, little blue suited guy. I'm not entirely sure what the icon is, but if you click on that, you get to download the presentations PDF for handout. And when I make handouts, I always do them two up like this, so that you get the slide that you're going to see as I present, and then you're going to get the notes page. And that's in case I forget to say anything that I meant to say. So if I forget today, if you go and read the handout, everything I wanted to say is in the handout, even if I don't manage to say it all today, if I run out of time, or if I have to speed up for the last few falls or whatever. So it's all there in the notes as well. And I think there's a recording too, so you might get that as well. But there's lots of notes to read afterwards, and lots of links to things that are a little bit outside of the scope of what I want to talk about, but that might be useful extra reading for you later. So I'm going to start by kind of setting the scene of all the different types of monitoring you have for your queue manager and where accounting and stats kind of fits in there, because there's very sort of breadth of detail that you can collect. You've got less level through to more levels of detail on that arrow on the left, and we'll kind of work our way down and see how we go. So we start with, you've got your display commands, your display queue status, your display channel status, that kind of things, the online immediate commands. What's the depth of my queue? Is my channel running? That kind of things. And as a source of information, you've also got error logs, and they're always on because they're always there as well. So those are kind of your immediate levels of monitoring that you've got. And then we'll move down slightly and we've got event messages. If something notable or interesting happens, the queue manager wants to tell you about it and you've enabled it, then you get an event notification. You've got the monitoring attributes that were added to channel status and queue status commands. So you turn them on with the monqueue or monchill attributes, and that gives you more detailed online status, things like put and get times, things like your exit time and net time on channel, that kind of things. So more detailed, something you have to enable, slightly more expensive to run. And you've got statistics, which is part of today's presentation, that are cut on a regular interval, on a drumbeat, on the statistics interval time frame, as information about various resources and how they've been used, how the queues have been used, how the channels have been used, and a kind of overall one, how the queue manager is being used for the various counts of MQI calls. More detailed again, you've got accounting, which we'll also look at in this presentation, information about the applications, so more detailed than just the resources. So it might be several different applications using one queue. So you get information about each of their applications. Activity trace, even more detailed. That's a distributed only feature, whereas the previous ones have all been platform wide. Activity trace, very detailed, very granular information about all the API calls applications are doing, everything right down to the length of the buffer being used and the GMO options being used and all that kind of thing. So very detailed. Again, slightly more expensive because it's further down our chart to capture. And then the last one, when all else fails and you can't capture anything else, internal trace is also there for you. Possibly you need help from IBM Service to read it, although the API part of internal trace is at least fairly decipherable. And I would say this arrow going from less to more down the page here is also the cost of running these things always on. So if you have internal trace always on, you know yourselves, that costs to run that. So you only turn it on when you need to, and maybe you try to target it at only the processes that you want to do. And the same is true of that application activity trace. You can target it at only capturing certain things. In the notes, I've left a couple of presentation links for things that describe activity tracing, those last two, because they're not part of today's presentation at all. But they are. So there we have sort of cheaper things at the top of the page, going to more expensive things, but also less detailed things going to more detailed things. So it kind of makes sense. As an example of how you might sort of use these more and more detailed types of monitoring as you try to delve into a particular issue, imagine you start with a queue is getting full and you've got a queue high event message that's led you to realize that this is happening. You might then use queue or channel monitoring to figure out, you know, what's going on here. You might check the last get and put the last get date and time on the display channel status or display queue status rather. If you've got getters, you'll see that number changing. You might drill down further using statistics. Have you got enough getting applications? It'll show you the number of gets and puts in the last interval. If your queue is getting higher queue depths, you've obviously got more puts and gets in that interval. You might start targeting applications by looking at accounting data, so you can see per application numbers of puts and gets. You might then drill down using activity trace to see a specific application and what exactly it's doing and the timestamps between when it did the get call, when it then was able to put the reply, that kind of thing. So each of these helps you to drill down further into a problem depending on what you're doing. Today, though, we're looking at accounting and statistics. So what are accounting and statistics? Well, statistics, and we'll look at this a definition in even more detail on the next slide as well. Statistics is activity about resource usage. How's your queue being used? How's your channel being used? That kind of things. Whereas accounting is information about what applications are doing, okay? On ZOS, these are written as SMF records, type 115 and 116. On distributed, they're written as PCF messages. The reason for this is on ZOS, you've got the SMF, System Management Facility, available on the OS, obvious thing to use to write statistics out for. On distributed platforms, no such component. There is no sort of cross Unix and Windows type system that they could have used. So PCF messages written to well-known queue names. This presentation is about the right-hand side of that file. Okay, so we're not touching on SMF statistics, but there is a link in the notes on a previous presentation that was on SlideShare that describes the ZOS equivalent version of this. So let's compare accounting versus statistics. So statistics is recorded periodically, okay? Accounting is also recorded periodically, but, there's a but, it's also recorded at the time when an application disconnects. Okay, so when an application is finished, we'll also get an accounting record for it. If it stays up and runs and connects for a long time, then you may also get periodic records being written, but otherwise it's recorded at disconnecting. Statistics, it runs using the statistics interval, so that by default is set to 30 minutes, 1800 seconds, and you'll get a record cut every 30 minutes. Accounting, there is also an accounting interval, but it only applies if you've got a connection that has stayed connected to Queue Manager for longer than that interval. Then it'll have several records cut during its lifespan, depending on how long it stays connected. And then it uses the account interval attribute. Those are two attributes on the Alter Queue Manager command. Statistics, the content of the record is one for each queue or each channel. It contains accumulated data for all the applications using that particular resource. Whereas accounting, the content is a record for each application, and it contains data for each queue that an application opened and information about that specific application. So they're very similar but different content. The statistics is what is being used. The accounting is who is doing it. Okay, so that's the sort of difference. When you look at the nitty-gritty, when you look at the actual fields that are being recorded, you might think, well, it's the same stuff, but it is a different perspective on the same thing. So you might be able to get the number of put calls that were done, but one of them is overall for the whole queue, and one of them is for this particular application when it used that queue. So they're different counts. Now, I've put a box around this particular section because I want to look at that in slightly more detail because I think it catches people out. So we said that accounting records are recorded at disconnect time as well as periodically if you've got a long-running application. So you might imagine, if you're thinking about how much data am I going to generate as a result of turning on accounting records, you might think, well, my accounting interval, 1800 seconds, that's 30 minutes. I've got 100 applications, so my expectation is I'll have 4,800 accounting records every day. However, reality might hit if you realize, hang on, my applications connect to the Queue Manager 30 times an hour. So that's only every 2 minutes. But that does mean that account interval never applies. And actually what you're doing is you're getting a record at every disconnect. So that's 72,000 accounting records a day. Okay, it's a very different number. So we have numbers of users who are collecting millions plural of accounting records per day because their applications are short-lived. Of course, those of you who have been working with MQ for a long time will know the best practice is not to have short-lived applications. You connect, you stay connected, you do what you need to do. And if you've got a period of a lull, then maybe you disconnect and wait for a new reason to connect again, but you don't connect, put a message and then close again and then disconnect. But I think there are a lot of applications out there that are doing that. And then you will get lots and lots of accounting records. And it's just something to be aware of when you start. If you turn accounting on, you may find there's a lot of data to wade through. So I just want to introduce how you turn on each of these things. And then the main meat of this presentation is going to be what questions you can answer with this data. And so you need to know how to turn the facilities on in order to get the data to look at. So statistics messages, you have 3 different types. You have Queue Manager API counts, you have per queue statistics, and you have per channel statistics. They're all written to the system admin statistics queue, and you turn them on. You use the statistics interval attribute, which we've seen already, defaults to 30 minutes on 1800 seconds. You can turn on MQI statistics using the stat MQI attribute on Alter Queue Manager. You can turn on queue statistics using stat queue on either the queue itself or Alter Queue Manager. Now, why is there 2? If you have a number of queues you want to turn statistics on for together, you don't want to have to keep altering loads and loads of queues. to turn it on and then altering them all again to turn it off. So what you can do is you can set those queues to have stat queue manager, which says take the value from the queue manager field, and then you can alter queue manager stat queue on and stat queue off, and immediately switch all those queues off again if you need to. Similarly, for statchel, you can set it on the channel, or you can set it on alter queue manager. So if you've only want to turn it on for one channel, you might say statchel high. Otherwise, you leave it as queue manager on the channel object, and then you alter queue manager statchel high and then statchel off. There's also a auto cluster channel attribute on alter queue manager, which you can either set differently to statchel, or you can say just use the same value that statchel is using on alter queue manager. So you've got the ability to turn that on and off for one object or for many objects fairly easily. And you get 3 different types of PCF messages written to that system admin statistics queue, one for MQI counts, one for queue counts, and one for channel counts, depending on which ones you have enabled. Accounting is also separately enableable. You can collect information about applications, either overall about their MQI counts or also per queue that the application is using. All these records are written to the system admin accounting queue, and you have an interval, as we saw a moment ago, account interval, so separate interval, so it doesn't have to be aligned with statistics. You can collect overall MQI accounting using account MQI on off, which is an alter queue manager attribute, or you've also got a queue and queue manager attribute, just like with statistics. So you can either set it for multiple queues with one single command with alter queue manager, or you can pick and choose specific queues you want to turn it on for. And there's 2 different types of PCF messages that will be written with this information. So that's how it gets turned on. What the main meat of this presentation is a selection of questions that I've come up with anyway, that you can answer with this data. Now, this is not the full set. There's bound to be many more questions that we could come up with. It's not an exhaustive list, but I've tried to design it so that it hits as many of the different accounting and statistics types as possible to let you see several fields in each one and give you an idea of what's there. I'm always on the lookout for more interesting questions that you can answer with accounting and statistics data. So if you think of any, do feel free to send them to me. I intend to turn the contents of this presentation into a series of blog posts. Part of the reason for signing up for to be a presenter at this conference was to kind of light a fire under me to get this written down. So now that I've got as far as writing it down in a presentation, hopefully I'll then be able to make the series of blog posts as well. So look out for those coming along. And so I'm always looking for more questions to add to that list. So this is a summary of the types of questions I'm going to answer, set a few groups of different types of questions, and we'll see if we can get through them all before the end of the hour. So one of the things that I always wondered when I was a new MQ developer in Hursley, when I first heard about accounting and statistics, I was like, what's it got to do with finance? You know, why is it called accounting? Isn't that like bookkeeping and stuff? What's it got to do with that? And I thought it was worth adding a little page about that, because I imagine other people might have a similar reaction. Is this a finance thing? Is this a money thing? And the answer is kind of, you know, there is a financial term called job accounting, which defined there, job accounting is the process of assigning incurred costs, variable and fixed, to a specific job, project or client. So it might well be, and certainly the MQ manager is designed to be able to do that, the queue manager is shared between many different applications or many different groups or projects or whatever. It was designed to be so some people have a separate queue manager of every application, but there's certainly no need to do that. The queue manager is designed to be a shared resource. So given that it's designed to be a shared resource, many different projects might be covering the costs of running the queue manager. And by that, I mean the dollar costs, whether that's paying for machines or the time for the administrators and so on. So how do you appropriately charge each project for the amount of money that they should contribute to the running of that queue manager? And so accounting, or sometimes known as chargeback, is one of the things you might do with accounting records. Not the only thing, but it may be the reason it was originally named that way. So how much should my department, or how much should each department using the queue manager contribute to the costs of having that queue manager? And you can do this using either of the two accounting types of records, either MQI accounting, which you turn on using account MQI attribute, or account queue. I suspect account MQI is enough. And what you're looking for then is, having collected the account MQI data, find a way of summing it all together that's fair on all the applications. So there's a number of things you could do. I've come up with 5 different ones, and you could probably come up with other ones as well, but it serves to illustrate some of the fields you are collecting. You could total up all the API calls that are made. Every get, every put, every inquire, every set, every MQ back, and so on, both successful and failing. And you could say, I'll make a percentage of the numbers. These guys had 50% of the API calls, those guys had 25%, and so on. And then you split the costs that way. You might total up only those API calls as successful, which means it would be free to get a truncated message, or it would be free to get told no message available. You might total up just the counts of put calls that made messages, so these are the application calls that, caused messages to appear. You might total up the number of bytes put, right? So somebody put in really big messages pays more than somebody put in really small messages, right? Or you might total up the number of bytes both put and got, So any of these algorithms might be suitable. I don't think, generally speaking, it probably matters which one you pick, as long as you do the same summing for everybody, because what you're trying to find is a relative percentage of usage of the queue manager. You will find when you do this exercise that there will be some system connections as well, be things like the command server or channels that will have counts and bytes associated with them as well. It's probably fair to total those up into a separate bucket that is not charged, and it's just part of the running of the queue manager. Now, we'll see on one of the later questions exactly the fields you get for identifying an application, but one of them is, of course, Apple Tag, the application name. Now, if your applications are not easy to identify, you might benefit from using one of the not so new MQ features anymore. You can now give your application a name, and that's what shows up in DisplayCon, that's what shows up in Display Queue Status, that's what shows up in accounting and statistics, well, in accounting specifically. So if you can't separate your applications out because their names are meaningless executable names, then you might want to look into that. So that's kind of outside the scope of the presentation today, but I've put a link in the notes for a blog post that describes how you do it. And you can either do it by changing the application, or if they're client applications, you can also do it by setting something in the MQClient.ini file. Okay, so the next question we're going to look at is, how busy are my queue managers? Okay, and you might want to know this because you need to know the quiet times. You need to do some kind of maintenance recycle of a queue manager, and you want to know when the least impact to the applications might be, and find the best time to do that. I'm just looking at the question here. Martin Packer's asked, oh, can I answer at the end? Okay, I'll come back to it at the end. So you can figure out how busy a queue manager is by collecting statistics data, either MQI, queue, or channel statistics. I would suggest that MQI statistics are probably good enough. So you use Ultra Queue Manager, stat MQI, and you gather that. And again, you're looking at, let's say, the API counts. You might want to just look at the puts and gets. Somebody who's just doing an MQ acquire or an MQ set or something like that probably doesn't mind if you cycle the queue manager on them. If somebody's doing thousands of puts and gets a second, then they might want to know. So graphing those counts would give you an excellent view of your quiet times, and then you can know when it's a sensible time to have an outage or to run some kind of heavyweight application such as a batch run. So classic things that you want to do with accounting and statistics are capacity planning and performance understanding of your system. So one of the metrics that is very useful when you start to do things like that is message arrival rate. So I'm going to look at that first, and then I'm going to, in a couple of pages time, make use of it for something else. So you want to know what your message arrival rate is. You're going to use Q statistics records for this. So your Auto Queue Manager stat queue on, if you've got many queues that you want to learn the message arrival rate for, or you might just turn it on for a single queue, Auto Queue Local stat queue on, and maybe also make sure that the Queue Manager attribute isn't turning it off completely, because the Queue Manager has two versions of no for stat queue and stat chill and various other things. It has off and it has none. Off is the way you just turn it off for various queues at once. None overrides what it says on the individual object. So if you're relying on the individual object attribute to turn it on and make sure the Queue Manager isn't doing the nobody's allowed to have statistics setting. You might also, when you're looking at a message arrival rate calculation, consider your statistics interval. So the default is 1800 seconds, which is 30 minutes. If you want a slightly more granular view of your message arrival rate, you might make that lower. Bear in mind that the lower you make it, the more data you collect. And so don't set it too short, I suppose. Even if there have been suggestions you can set, statistics down to a few seconds, I don't think that's really that helpful most of the time. So having set that up, you're going to monitor the statistics data written to your system admin statistics queue, and you're going to get a number of records. The queue statistics data includes 4 fields that are interesting for this particular calculation. You're going to get put counts for persistent, put counts for non-persistent, put 1 counts for persistent, and put 1 counts for non-persistent. So you can add all these 4 counts together, and that gives you a count of all the puts. Okay, and that's what you want for your message arrival rate. So if you need an hourly message arrival rate, total of all puts that you've collected across all the intervals, divide by the number of intervals, that's giving you a 30-minute average, multiply by that by 2, and that gives you an hourly average. Similarly, if you need a daily rate, same thing, multiply it by 48, that'll give you a daily rate. You might also be interested, especially if you've got quite a variable message arrival rate, something that you would be able to see if you graph numbers like this, is you might want a peak hourly arrival rate rather than an average, in which case find the 30-minute interval that gives the highest number, and then maybe double that, and you'll have an hourly maximum possible arrival rate. So that's calculated message arrival rates. A similar thing that's also very useful, and we'll see exactly why in a couple more slides time, is data arrival rate. So rather than the number of messages, we're thinking here about the number of bytes. So same kind of thing, you're going to turn on statistics, but this time you're looking at fields put bytes, persistent, and put bytes, non-persistent. So there isn't a put 1 bytes as well. There's just 2 fields here. So we add these 2 together to get our total put bytes, and then you can get an hourly rate again, or a peak hourly rate, same kind of maths. I won't go over it again, but that gives you a number of bytes expected to arrive in an hour, or the maximum number of bytes you're hoping ever to see in any 1 hour. So both of these calculations lead us into a question: how can I size my queue? So a good queue is an empty queue, as they say. We always like to see that queues are being processed all the time. However, outages are planned. You get application maintenance windows, you get remote queue managers being cycled, and you have unplanned outages as well. Outages are a fact of life. And to be honest, that's why you have a queue, right? Queues are there to be the buffer when something bad happens, even if it's just an influx of messages for a brief moment, or whether it's an outage of some sort. That's the reason you have a queue. Okay, so outages are a fact of life. What you need to understand is how long an outage you want to be able to cover. Okay, and that's a business decision. The business is going to decide, we need to cover, let's say, a 4-hour outage. If it goes on beyond 4 hours, then, you know, we're fine with applications being told that queues are full and what have you, but we need to be able to handle 4 hours. So we're trying to basically decide how to size my queue so that I can handle what the business has asked for. The business has asked for me to handle a 4-hour outage. So how many messages do I imagine are going to arrive in 4 hours? So I have calculated my message arrival rate on the previous slide. So that's my hourly rate multiplied by the number of hours, probably multiplied by 2 in classic time-honored IT estimation tradition, that you double everything that you come up with. And that tells you how many messages that you expect to arrive in that time frame. And so you can make sure that the max depth of your queue is not less than that. Okay. Now, similarly, in modern versions of distributed MQ, you might also want to consider sizing the queue file. If you've got small messages, it probably doesn't matter. You're probably never going to get anywhere near the size of the queue files maximum anyway. But if you've got big messages, then that data arrival rate might also be useful. The quantity of data that's going to arrive in that time frame, and you can set your max file size, which is the size the queue file can grow to, in order to cope with that amount of data rather than that number of messages. So both of those numbers, those metrics you can calculate, can help you to size your queue accordingly. Now, one of the mitigations that you might choose to make use of when you're thinking about outage management is capping the expiry. So there's a feature that was added to MQ as a custom feature way back when, and more recently as a real attribute. And it's a way of setting the expiry on messages on a queue when the application hasn't done it, but should have done it. Okay, the application didn't set the message expiry, and there might be 2 reasons for that. 1, they forgot, or 2, it's incredibly important these messages are never expired. Don't override the second one. Okay, but there are plenty of examples, I believe, out there in the world of applications that should have had an expiry on their messages and didn't, and administrators get the phone call in the middle of the night as a result. So cap expiry was invented by IBM Hearsley to help with these situations. So you might do that as part of your outage mitigation as well, that, you know, you've got a queue, you want to be able to maintain a 4-hour outage, but actually these messages are pointless after they've grown to 2 hours old, so you might as well add an expiry to them there too. If you do that, the business may be interested to know how many messages you threw away as a result of that. Okay. Oh, there's the commands for setting cap expiry. Oh, bear in mind, this is expiry. So just like it is in MQ application programming, you need to know what the units are. And remember that these are tenths of a second. So cap expiry is 36,000 is 36,000 tenths, which is an hour. Okay, so make sure you get the units correct on that one. If your queue manager is pre-931 or on ZOS, which hasn't got the real attribute yet, then cap expiry is put within the custom field, as the second example shows. So yeah, if you need to tell the business how many messages had been expired as a result of doing this, and then queue statistics has got that one in it as well. So if you're collecting queue statistics, you can look for the expired message count, and that'll tell you how many messages got expired in each interval. So you can total those up for the duration of the outage if you need to. There is no separate persistent versus non-persistent count for expired. There's just a single count to tell you how many messages were expired overall. Just checking the chat in case there's any other questions as we go on. So if you're an MQ administrator, you may well have set up your queue manager to report event messages when a queue reaches a depth that you consider to be high. So default is 80% of the maximum depth, but of course you might have changed this. And you might never reach this alertable situation, but you might be curious to know how close you come. Okay, so that's the question. How close am I to queue high? So you could find this out by repeatedly inquiring from the command server, what's my cur depth? What's my cur depth? I mean, this gives the command server a lot to do. And of course, you might also miss some peaks in between issuing one command and the next. So another way to do it is to use statistics data, because then you won't miss any peaks because the queue manager is capturing it all for you. And then you can look at the queue max depth field. That'll tell you how high that queue got in that interval. So again, you can graph something like that. Graphing it might also show you whether you have a trend that the maximum depth you reach is gradually increasing, in which case you might start thinking about adding additional getters or other mitigating factors to improve the responsiveness of that application so that you never actually hit the queue high situation. On a very similar vein, queue service interval events is something you might have set up so that you are given an alert if messages on a queue are not processed in a timely manner. So if they don't meet the SLA because they took too long to get round to them, then you might get an event. But you might never have actually received one of these queue service interval high events, but you might want to know how close you have come. So how close am I to service interval high is the question here. Again, you could do this with online status commands. Display queue status, if you turn on mon queue high, will show you queue time, which is how long a message was on a queue before it was got by an application. You might miss peaks, of course, with this. And also it's worth noting that queue time doesn't increase until messages are got. So this rolling average that queue time gives you is only calculated once the message has been got off the queue, because you don't know how long it's been there. You do have message age on display queue status, which will continually go up if nothing is happening on the queue, because the oldest message is getting older and older. But queue time doesn't update until somebody gets it off the queue. So queue accounting data this time has time on queue max and time on queue for persistent and time on queue max for non-persistent. We don't have this in statistics data. We have to collect this one in accounting data. And I think that's related to the fact that it's not calculated until a message is got by an application. So there'll be something tied into that. It's also worth noting here that when you set up a queue service interval event, the unit is milliseconds, but when you're displaying queue time or when you're looking at time on queue max, that's microseconds, okay? And that's fair enough, because I don't think you'd ever want to set up an interval to say, I want to be notified with a granularity of microseconds, but it perhaps is interesting to see the times reported that way. Statistics does have a time on queue, an average time on queue, but it doesn't have the max that you need to answer this particular question. It might, though, be worth using queue statistics average time on queue to graph and to see if there's any trends that this is going up. And again, look into improving the getters before you get to the alertable situation. So next question, how heavily loaded are my channels? So one of the major factors in the behavior and the efficiency of queue manager to queue manager channels is batching. Okay, channel batches, how many messages get sent in one distributed transaction. So the sender says, have I sent batch size messages? So that's usually set to 50. If it has, it'll end the batch. It also, since about version 6, has had something called batch lim, which says, actually, what you're trying to say when you size a batch on a channel is how much data am I willing to retransmit. So if I've got really big messages, I probably want a smaller batch size. So batch lim is actually just batch size, but measured in bytes. So once I've sent, I don't know, 100 megabytes of data, then I'll end the batch. And thirdly, if I've reached the empty transmission queue state, then I also end the batch. So we have, and this is what's coming up on the next page, we have the concept of complete batches. Those are ones that have been ended, because either batch size or batch lim were met. And we have incomplete batches, which are the ones when we reach the empty transmission queue state. So if you want to discover how loaded a channel is, traditionally, back in the bad old days, before we had any of the monitoring or statistics or stuff, you would calculate average batch size by doing a display channel status and taking the number of messages, number of batches, and doing a little bit of mathematics, and that was your average batch size. That didn't give you peaks and troughs because it was an average over the lifetime of that running instance of a channel. Then in version 6, channel monitoring with mon_chil_high was added, and you got X batch size, which is short for achieved batch size, which is a rolling average. And that was a slight improvement, I think, on the traditional just doing the maths yourself. But again, it's not giving you all the information, and I think channel statistics gives you a better view of it. Here we turn on channel statistics using StatChil. Actually, I think that should say StatChil_high rather than StatChil_on. I must get that corrected. Or, of course, you can use the QManager attribute instead, and you get 4 fields in channel statistics that are useful here. Message count, just as a show similar to what you could get on channel status, but then you get a full batch count, an incomplete batch count, and you get your average as well. So those are going to help you decide how your channel is performing, how it's managing, coping is perhaps the better word. So what does this batch size tell you? So if you get incomplete batches, it's not a bad sign. It's not perhaps as efficient a way of moving messages, but it does mean your channel is keeping up with the workload. So if it hasn't got messages to send, it can't fill a batch, right? It's just going to send the ones it's got. So that's fine. It's having breaks in the time frame. It's got a chance to catch up with any lumps of messages that arrive all at once. So it's keeping up with the workload. So that's a good sign. Full batches is the most efficient way, of course, to move messages. But if you're continually seeing full batches all the time, the channel may be close to not being able to keep up. Okay, if you have bursty traffic, and you know that you get, a whole dump of messages on the transmission queue, and then the channel clears it, and then it gets to pause for breath, and then there's another dump, then that's fine. But if it's constant, then you may be approaching a point where it can't keep up. So again, graphing those numbers over time would be able to help you to understand that trend. And have you got chances for the channel to keep up with the workload, or is it just constantly running and trying to keep up? So that's what to do with those particular batch numbers. There are other channel metrics as well. So if you have channels, they are of course running on top of the network. They're also aware of the time they spend using the network. So they collect the network time on any line turnaround. So when they do an end of batch flow, or when they do a heartbeat flow, they'll collect the time spent and in that line turnaround. You can see this a long and short term rolling average in display channel status using the net time attribute. But you can also, rather than polling the command server all the time, you can also get this from channel statistics. In each interval, you'll get a net time min, a max, and an average. So again, you might want to graph this and make sure that you know what your normal is, so that you can spot when you've got things that are abnormal. So when things start looking a bit weird or starting to increase, you might be able to spot a network problem before the network people spot it. Who knows? Similarly, you have the same sort of thing for exits. You want to collect this. Again, you could do it with channel status, but you might miss things. And of course, you're hammering the command server, constantly asking it. So channel statistics also has exit time, min, max, and average as well. So again, worth capturing and understanding your normal so that you can spot if something starts trending in the wrong direction. And both of these, whether you're using display channel status or channel statistics, these numbers are in microseconds. Tidying things up. So this is kind of a title page. One of the jobs for MQ administrators has always been to figure out whether an MQ object is still needed, okay? Even though it's the applications that really, I think, should be making these determinations. It's often left to the MQ administrator. So to determine if QX is still being used, you can use Q statistics records, turn that on. It's not a difficult decision to make to turn on Q statistics on a queue you suspect is not being used, because it's not going to cost anything if it's not being used. Monitor the statistics written to the system admin statistics queue and see if that queue comes up. However, as Carl Sagan said, absence of evidence is not evidence of absence. So how long should you monitor such a thing for before you can decide this queue is not needed anymore? You know, do you monitor for a week, a month, a quarter? You know, do you have queues that are only used once a year? All you have here is an absence of evidence. So you cannot prove this queue will never be needed again. All you can prove is for the time period you've monitored it, that it was not used, and this suggests it's no longer needed. Now, for the supremely paranoid among you, you may have realized that there's no difference between nothing being reported because nothing is happening on the queue and nothing being reported because monitoring is not working for some reason. Okay, so you might find it comforting to occasionally open the monitored queue and, I don't know, browse for some messages because there aren't any, in order to get a queue statistics record that shows a browse fail count. And then you know monitoring is working, and still there have been no records. So that's something to bear in mind. A very, very similar page next for MCA channels. So I think for time, I will just very quickly go through this. Use channel statistics, stat chill high. Again, you're monitoring for some mention of that channel, and you have to determine how long to monitor for. You could equally monitor the transmission queue of a sender channel instead of the channel itself, if you want to do everything with queue statistics, and that would be a similar way to figure it out. However, I mention MCA channels here because I want to go on to the next one, which is MQI channels, that is Servacon channels, because they're different. So we saw channel statistics showed you information about queue manager to queue manager channels, but Servacon channels are not covered in channel statistics records. Instead, you use accounting records. Okay, so when accounting is captured for an application, for example, using accounting MQI, then there's information in the record about the channel that that application used to connect to the queue manager, and that's the Servacon. So again, you're going to monitor it, looking for any mention of your Servacon channel name. If you're just looking to delete an unused object, then this is basically the same as the queue and the channel foil previously. You monitor for as long as you feel is appropriate, and then maybe you can delete it. If, on the other hand, you're trying to find the last few users of a soon-to-be deleted object, the accounting record also identifies the application name, the user ID, the connection name, and the channel name, because that's what you're looking for, of that application. So if you do get records saying this application just connected and using this channel, then you should be able to identify that application owner and go and ask them to change and use the new channel they're supposed to be using. I mean, I know if you delete the channel object, then that would encourage them to switch too, but that's not quite as friendly as, you know, giving them a heads up in advance. So there's sort of two use cases there, really. So the next question, does a publisher have any subscribers? So I've seen a few people talking about this, that they've got this application that's been going for a year or two, and they don't think anybody's using it. They think this publisher's just out there kind of wasting resources, and they want to be able to get rid of it because they don't think anybody's actually listening. So before we look at accounting and statistics, I just want to say that an application can determine this itself, okay? You can code the MQ-PMO warn if no subs matched put option when you do a put to a topic. And then that will mean that if there were no subscribers when that message was published, you get the MQRC no subs matched return code. Okay, so the application can tell itself. It doesn't need accounting statistics. However, if you've got an application that didn't code this, then you need another way to answer that question. So does a publisher have any subscribers? So there's two answers here. The first one's really easy if you only have a single publishing application, okay? If that's the case, you can use MQI statistics, monitor the statistics queue, and there will be two counts in there, the published message count and the published persistent, and the published message count non-persistent. Now, this is the number of messages delivered to subscribers, not the number of times an application attempted to publish to a topic, which is another field, but a different field. So if these counts are 0, then you have no subscribers for that publisher. Trouble is, if you have 2 or more publishing applications, then these counts, unless they're all not being listened to, these counts will contain published counts for all the applications, and you won't be able to tell if you've got one that is not needed anymore. Okay, so then we have to get a little bit more creative. So I briefly want to mention a PubSub feature we're going to make use of in this creativeness, called sublevel and pub level. So normal applications in MQ, when they publish at level 9, and when they subscribe at sublevel 1. And it's possible to subscribe at a higher level, let's say sublevel 5, and intercept publication, make some changes to it, and then republish it down at the next pub level. So you can use this for annotating, for example, publication messages before they go to the majority of the subscribers. Okay, so, and there's a blog post link in the notes that describes exactly how to use pub level and sub level in this regard. However, there is an extra thing. If you subscribe at sub-level 0, lower than the default, then you will only ever receive publications if there were no sub-level 1s, because the sub-level 1s aren't going to be republishing to you, right? So if there's no sub-level 1s, then you start getting publications on your subscriber queue. So you could define yourself an administrative subscription and a queue, as the commands show there. You might want to change the topic string to your specific application's topic string. And then if any messages arrive on that queue, nobody else got them. No other subscribers got them, right? So that's one half of the answer. Okay, so does a publisher have any subscriptions? Let's monitor that sub-level 0 queue. But what you want to know is literally none of these publications are of any use. Nobody's getting any of them. So you want to know that not only did you get some of them, but you got all of them on the sub-level queue. So you need to know how many messages arrived on the sub-level queue, and you need to use counting MQI records to see how many puts to topics this application did. So you've got put to topic count, persistent, non-persistent, and put one to topic counts, persistent, non-persistent. So you add all those together and compare those to the count of messages put to the sub-level 0 queue. If they're the same or extremely close, it does look like your publisher has no interested subscribers. The reason I'm hedging my bets there a little bit with the same or extremely close is because we're comparing statistics with the queue and accounting with the publication application, and they're not lined up, or they're not guaranteed to be lined up. So you might have a short-lived application, so you're adding together lots of accounting records. You might have your accounting interval and your statistics interval are different, or even if they're all the same, they're not necessarily going to line up. So over time, the numbers will match, but in any particular interval, you might find that there's one on either side of the boundary and the numbers are not quite identical. But if they're very close, then you look like you've got a particularly uninteresting publisher there. So another thing that administrators are especially keen to tidy up on is back-level clients. Have you got old clients connecting into your queue manager? So display channel status has the remote version field on it, but you might miss short-lived connections, right? You have to catch them when they're connected and show up on display channel status. And if they don't show up, then you don't get to know about them. So you can use MQI accounting records for this, just a simple one, don't need to use queue accounting. And every time an accounting record is written, you'll get this information. So you're not going to miss any connections because the queue manager is going to catch them all for you. So the accounting record identifies the application. You've got that remote version field, so you can immediately see if you've got any old ones. And of course, you've got the connection name, channel name, application name, and so on. So you can identify the application owner and go and ask them very nicely, could they please upgrade their client application version or their client code version before you put in some kind of change to the queue manager that means they're going to stop working because they're using something that's so old. And by the way, there are a few examples now of APARs that will cause really old clients not to work anymore. So try and get your client code versions to be a little bit more modern. Something at least in service would be nice. Okay, we're going to very hurriedly finish through the last ones. These are just some things. If you happen to be collecting accounting information, you might be able to tidy up some of the things your applications are doing on. So the first one's what I call the wrapper problem. Using accounting queue records, you can see the number of open counts and the number of put counts. And if you determine that an application has the same number of opens as they've got puts, it's highly likely that they're doing open put close, open put close, open put close. And as we all know, that is not a particularly efficient way to run your application. So you can have a chat to them and get them to maybe do the right thing. If you have a large number of failed MQ gets in your accounting records, you've got get counts, get fail counts, browse counts, and browse fail counts. What you might find that you've got, if you see this, especially if you've got more than one a second, is you might find you've got an application that's forgotten that the wait interval isn't in seconds, it's in milliseconds. And so they coded a much smaller number than they needed to, and so they're getting lots and lots of failed gets, multiples per second. So if you see a high number of MQ gets, that might be worth having a chat to the application team to see what units they use there. Or you could use application activity trace and check it out for yourself first before you go and chat to them. But this will give you a hint that there might be something worth looking at. Short-lived connections. Again, we mentioned this near the beginning of the presentation, but I'm sure many of you are very aware that MQCon, especially for clients, is the most expensive call that an application can make. So whether you're doing network connections and then SSL or TLS handshakes, that kind of things, it's extremely expensive. So you want to find all the short-lived connections, and those are the ones where you get an accounting record that has both a connect time and a disconnect time in the same record and a sequence number of 1. And then you can spot that's a very short-lived application connection, and you might want to have a chat, see what they say. And API failures, if you're just collecting statistics MQI, maybe just in the first instance to see if anything bad's going on, and then drill down and use application MQI counts to see which applications it is. But if you see high numbers of failures in any of these fail counts, that's definitely worth investigating. Either the application is ignoring the bad return code, which I certainly have heard of such things happening, or they are collecting the reason code, but then they don't care and they issue it again anyway. So any high numbers of failures is definitely worth investigating. And so that's a summary page. I've put in the notes page behind this the links to each of the 5 pages in the IBM doc that show you all the fields. We've pretty much covered almost all the fields here. I think we managed to miss a number of put retries on child statistics and the purged message count on MQI statistics and Q statistics, but we've kind of covered most of the rest of them. However, there are always other ways you can use all the data that you collect as well. So I'm sure there are many more questions we could look at. Now, if I have time, what have we got in 1 minute? We'll have a very quick show you of what's in that you can read later. So there are published statistics in MQ now as well. They are published to well-known topic strings every 10 seconds. You can't change that 10 seconds at the moment. Whether that will change in the future, I don't know. Some of them are very similar to the Q and stat MQI statistics we just looked at that are sent to the queue. In the notes, I've put the page that shows you every single field you can get for this. So if you're interested, you can have a look. They're identical, except for StatQ has got 3 extra fields in the published version that it hasn't got in the queued version. I've got a link to an idea. If you think these should be the same, please go vote for that. And just to mention tools, we haven't talked about tools. We haven't showed any examples of output data today because I wanted a slightly higher level presentation to get you interested in using accounting and statistics and see what you can do with it. But IBM supplies a couple of samples, MQS Mon, which is for reading from the accounting and statistics queue, if you're doing the sort of traditional form of accounting and statistics, and the MQS RUA, which is for subscribing to system topic strings and looking at that published data we just mentioned at the end. Now, these are samples and they're not the sort of thing that's really that suitable for sort of running all the time as a monitoring tool. They're a sample. So there are plenty of commercial vendor solutions out there that do this as well, that are designed as long-running background tasks and so on. I can't pretend to know about any of them apart from one, which is MQEV, which is the reason why I'm elbow deep in all these bits and bytes in the first place, because we've got one, just FYI. So just to summarize, since we are literally on the last 30 seconds, you can answer many and varied questions about your queue manager and the applications that connect to them by using and collecting and analyzing accounting and statistics data. I've shown a small example set of questions. I'm sure there are many, many more. there are plenty of ways to analyze the data in many different ways. Graph it, look at trend analysis, all sorts of things. So I hope this has at least opened your eyes a little bit to what you can do with your data. And any questions, do your feedback. Any questions, I am happy to take them now, or my email address is there. Please feel free to email me, that's fine. And I'll be writing a whole bunch of blog posts about this as well, so look out for those too. So,
yeah,
pant.
We have Martin that posted a message and he's still in. I do appreciate that, Martin. You can unmute yourself now, but I do appreciate that you might have DB2 sessions to run soon. So you want to just ask more your questions?
Somehow I succeeded. Thank you.
Nice.
Yeah. So DB2, as we know, originally had a snap time of 30 minutes, right? Which is bloody useless, particularly when you've got cumulative counters and stuff like that. I spotted your 30. Which I think was actually related to accounting rather than statistics. But I think the question is...
No, they're both. They're both.
It's both. Now, is the default still a rather rubbishy 30? Or in other words, a customer would have to go and take steps to get a decent statistics and accounting interval, or what's
they just do an alter queue manager command and they just specify a shorter number. It's quite simple. I think as a default it's not bad in the sense that if you turned on accounting and statistics without realizing that you had to set a statistics interval or an accounting interval, you might generate less copious quantities of it if you didn't realize what it was going to do. So at least, you get a reasonable number in the first instance, and then you go, oh, what am I supposed to do with all these messages now? All right, I better read them before you change it to 10 seconds or something and make several million of them and definitely not know what to do.
The new DB2 default, by the way, is 10 seconds in version 13. So
where does DB2 is this DB2 writing to SMF though?
It's either GTF or SMF. So
you've probably at least got something capturing the data when you do that with DB2. Whereas, and the same is true for MQ with SMF. MQ SMF statistics used to be measured in minutes. And in 9.3, I can't remember the digit, 9.3x, they changed it to be minutes and seconds. So they gave you two fields, one to put the minutes in and one to put seconds in, so that you could literally put it down to 1 second if you wanted to. On distributed, because they're writing it to a queue, I don't know whether we would ever see the default be lowered to such a state, because you would just blast and fill the queue before you realized you'd done it. So first, I think you need to have an application consuming it and then decide to set your interval a little bit lower.
But if you can
just because of the mechanism,
something bursty, then you'd obviously want to drop it. And I don't know whether customers typically do drop from the default, or it sounds like they don't.
I think if you're collecting this stuff so that you can look at it, and in looking at it, you realize that your granularity isn't good enough, then you drop it.
Right.
That's, that would be the kind of...
I would expect typically people don't drop it then.
I would expect it. When people first start, they don't drop it. And then they collect it and look at it and go, wouldn't it be nice if I could tell that every 15 minutes instead of every 30 minutes? And you go, well, change your interval then. And they go, oh yeah. So it's as simple as that. It really
queue managers. Yeah, I understand. Okay, that's fine. Thank you. I understand the lie of the land now. Thanks, Brian.
Thank you, Mark. And thank you very much for the presentation again. As I say, we ran out of time by a bit now, so let's just close the session now. But I appreciate your time and your session. It's going to be recorded, so as I say, you will be able to share this going forward as much as we will be able to share with our peers as well around our area. So thank you very much again, and enjoy the rest of the conference, and then good night to you, Maura, potentially.
Thank you, guys. Have a good day.
And you. Bye now. Everything. Bye.